Okay, hey and welcome to example 3. In this one we can have the exact same setup as example 2 with the packed object and the extra attributes here to bring into .NET. Instead, in this one we're going to focus more on how to do collisions and the static object. So, let's say we want this box to collide with some different things here. I've created 2 extra boxes. I'm going to merge them together just to show what the collision I want is going to happen. So I want these 2 boxes to collide with this. Alright, so how do we do this? Well, we're gonna bring these 2 boxes in as something called a static object. So everything is the same here. The null is at the end, out top 3. We're gonna look at it in .NET. And these 2 I've added another null at the end called out2.static and out2.static1. I just used a simple box, a polygon, and transform it up a little bit. Let's dive into .NET and see how we can work with this. So, here is everything we want to be a collider. The ground plane and the 2 boxes. Okay, so how do we get our packed pack object, to collide with these? Well, first of all, I'm gonna go through it there. Arbit packed up connected to the bullet solver connected to the merge, and the merge connected to a static solver. So static solver is basically needed if you have more than one colliding object. And therefore, we have a ground plane and we have 2 other objects. We're gonna merge them together and input them to the first input of the static solver. Then the static solver goes into the merge, and this now becomes the whole colliding object, basically. So if you can see it, we can solve it, but nothing happens. So what is a static object? Well, a static object is the same, almost the same as a RBD object. It simply brings in the geometry. It has some physical attributes to it, like bounce, friction, that sort of stuff. You can bring in deforming geometry as a static object. The main key difference between these 2 is that one is active and one is not. And I'm gonna prove this by doing a simple thing here. I'm gonna create another bullet solver and I'm gonna connect the first input to this static object. So as you think now, since I connected this static object here to the bullet solver and I connected gravity, it should be pulled down, but it's not. So basically, physical forces can't act on the static object. They are excluded, basically. So if I connect the RBD object here and I have gravity, we can clearly see that it's falling down. So that's the main difference. But that's cool. So basically now we have the colliding objects here and the active objects here. We put some gravity to that and let's see what happens. It collides. So that's basically how that works. You can see the collision perimeter of these by going into collision. Clicking here, display geometry, and offset clicking that, and show collision guide. This basically gives you a representation of the volume that will collide. You can switch on and off here to see if it's accurate enough, and this is obviously accurate. So that's great. Sometimes you might have to go in here and kind of mess with the uniform divisions to get a quality enough to get a good collision surface. Some very weirdly shaped objects can be kind of difficult to get that to, so you have to be smart about that sometimes, but yeah. Anyway, that is how the static objects work and how the static solver work. So basically how you do it is you just locate the object here and it will bring it in. But more on this on later tutorials, I think. Read through this and go through this example, and thank you guys for watching. That was everything. Let's zoom out again and see. Boom, boom. So yeah, that's static objects and static solver. Thank you guys for watching and see you next tutorial.